Hey YouTube, we're going to do a video today on Reproduction PCB for the arcade game Ice Cold Beer, or Zeke's Peak for the PG version. But this was made by a couple of guys on KLOV, and they gave a bill of material to build this. And this is going to be kind of a rants and raves, but there's going to be a lot more ranting than raving, unfortunately. Now, my experience with Reproduction PCBs, the bar is kind of set high because I've done quite a few, probably about 7 or 8 of the dumbass boards for pinball machines, and Victor Tan or Dumbass does a really good job of supplying a bill of materials and then alternate parts that could work, and he's built the things that he's selling, so it's really easy. If you ever run into any questions, he'll instantly tell you a good solution. Now, with this board, I finally have it built and working, but there were a lot of issues, and I was kind of on my own for support here. Now, I bought this secondhand as well, so someone had bought the bare PCB from the gentleman on KLV, and then they gave him a PDF with the bill of material, and then years down the road, he sold it to me. So I don't know if their process is better now, but the material that I received to build this board would make it almost impossible to get this to work without having a factory PCB, which you see on the top, to compare things. Because when I had this one built, it actually worked except for the sound, and there's some major issues here. So going through the actual manual, the bill of material that they included was just copied from that, but it's pretty obvious that it was never checked against the factory PCB, because if you've been in this hobby any length of time, you know that the manuals usually have some errors in them, and you can't only just trust the bill of materials, you need to look at the schematics too. So kind of going through here, they pulled all of the lists on the left. These are just directly pulled from the manual. And then the columns on the right are the counts. So if you're trying to order parts from this, you're going to get pretty frustrated, because if you follow their counts, there's so many errors on there that you would probably end up having to order things 2 or 3 times to get the right amounts. So we're going to kind of go through there, and then I'm going to give you some recommendations on what I did so that you don't have so much trouble if you're trying to build one of these on your own. And again, this probably should have been stated from the people that built these originally or tried to sell them. They should tell you some good substitute parts, because a lot of these on this PCB are obsolete and very expensive, and there's actually cheaper alternatives. And you can kind of see what I'm getting at here with the first one. So thinking about the column that they made in the counts, I want to go through here and correct everything that I remember. I'll also make a disclaimer that these are the mistakes I saw, and I do have a working board now, but that doesn't guarantee that there's some smaller difference on these PCBs that's not creating an obvious issue right now either. So I believe this to be fully working and correct now, and I play tested it in a machine, but there could still be a part here that doesn't completely match that. I just haven't noticed it yet. So going down our list for the included PDF, again, this is just the count list over here, but the first thing I would suggest is U11 is the factory 5-volt regulator, which is a 323, which is that big bottle cap transistor on that heatsink. These are long obsolete, and they are highly counterfeit items. So if you're trying to find LM323, I think I shopped around a little bit, and I think the cheapest one from a reliable source was anywhere between $20 to $60. Plus, you would also have to put in this large heatsink, and I didn't price that out, but I'm guessing that's probably a few bucks as well, because this kind of regulator will kick out a lot of heat, so you need to dissipate that. Now, the better solution here is to get EZSBC PSU5 regulator, which is used a lot on pinball boards. And this is pretty much a switch mode regulator. And then this also adjustable via this little pot. You can bump it up or down from exactly 5 volts. But you'll notice that there is no heatsink required, because this thing doesn't piss out heat like a bottle cap transistor. And also this alternative is 10 bucks versus what you would probably likely pay $30 and up for that. So again, this should have been on the list saying that this is a better, more modern, and also cheaper solution. And then going off of their counts for some of the ICs, these would be the PIAs. So the 6821s, you can use the A or the B speed, but they list U26, 27, and 28. but on the factory board, there is no third PIA, and they say this in the manual too. So you don't want to be buying 3 of those because those are kind of expensive chips. And their count anyway should have been off of this. It should have said 3, but there's not 3, there's actually 2, but it certainly is not 1. Also in the manual, the memory chip at U13, which is this guy, it just says a scratch RAM, but it's actually a 6116. So you'll need to know that when you order your scratch RAM. And then the amplifier, which is on the vertical heatsink here. The factory one is a 2002. That is long obsolete as well. And the one that's a little bit easier to find, but is still obsolete, it's just easier to find, is a 2003. And that seems to work fine that I put on this reproduction board. So again, it would be really nice if they saved you the headache and said that you'd have trouble finding the exact factory parts because they're obsolete, but this cheaper and more available option is going to be a lot easier. Now, these 2 capacitors aren't stuffed. That was confirmed on the factory board. And then they have all of these capacitors listed, and you'll notice that most of these axial capacitors, some of them on the factory board are glass, some are ceramic, and then you have some kind of, I'm not exactly sure what kind of cap that is, but I'm guessing that it's not too picky on what kind of caps because I just went with all axial ceramics. And then there's obviously some tantalums in there, but the axials I just went with ceramics and they seem to work fine. But in the manual, they're just listed as these values, but on certain ones, there is a requirement for the tolerance. So you do want to pay attention to that because if it's in a sound circuit, it might give you kind of distorted sound if it's not within tolerance. So in the manual, these ones were listed as 10%. These ones were 10%. These ones had no percentage on them, and then these ones were 10% as well. The only one in this list, though, that was 10 was 144. So you probably want to be careful with those percentages just so that you have the right kind of, I should say, the right tolerance of cap in the right spot. The other thing on these quantities, like there are a lot of these caps. There's 106 of them. When you're shopping around for parts in bulk or in quantity, you're usually at your best price break above 50 or 100. And instead of going through here and actually counting that there was 106, I just ordered probably like 115, just so I'd have a few extra on hand in case there were a few that the parts list missed. But you're already at probably the cheapest possible without getting into the thousands. So just kind of add a few extra there so you know you're covered. And then further down the list, the rest of the caps looked fine. I actually went to Arcade Parts and Repair for the axial electrolytic capacitors. But now on the resistors, R10, it says is not stuffed. And I might not be able to find that immediately. It was somewhere kind of on that top edge by the edge connectors, but it was actually stuffed on the factory board. And I don't know if that's R9. I don't know if that was R10. It's in there somewhere, but because there's R11, I don't know if that was R10. It said it was not stuffed, but it was on the factory board, and it's not really connected to anything. Yeah, there's R10 right there. So I just made it the same value that was on the board. I don't think it's in circuit with anything, but rather than have a blank spot in my board, thinking I forgot something, I just put it in there. And that R10 is actually 150 ohm down here. So again, kind of going through and correcting some of these quantities down here. 43 through 44 is going to actually be 2 quantity, 20 to 26 is actually going to be 7 quantity. And then with these, again, they didn't update this at all. These are the drive transistors for the motors. And it's a service bulletin that these should be upgraded to 1 watt resistors instead of 1/4 watt. And they should be the metal film ones that are burn proof. So that's these ones. So these are 1 watt metal film resistors, and that's the service bulletin. And I've already upgraded my stock board to that anyway, just because those commonly burn because they were undersized from the factory. So again, it would be nice to have that if someone's building their board. The other big mistake on here that actually caused the reproduction PCB to have no sound. In a track mode or game mode, it would just kind of sit there and buzz. It would actually play none of the game sounds. It would just have electrical noise on the speaker. I'm going to try and stitch in a video at the end that kind of demonstrates or talks about what that would be like. But that came down to R102 in the bill of materials is incorrectly listed as a 9.1, but on the schematics, it's actually a 9.1K. And again, they didn't, I'm not really sure how they claim that they built a working board, but with that error, they would have never had any sound. So I'm guessing whoever built one of these actually didn't look at this bill of material at all. I'm guessing that they just copied the values from a factory board and then stuffed the one based off of that, because this is obviously wrong. And with this list, you cannot get a working PCB. So this one will actually cause, I think this was tied to the 12 volts on your LM339. And then that actually causes no sound at all, if that's, because I mean, you're supposed to be 9.1K and you're putting a 10 ohm resistor there. You're pretty much just tying it directly to 12 volts, and it just made noise. There's another issue here with the sound too that we'll get to when I get to the diodes, but those are the two main issues. Because again, I had a fully working board here, but the sound just was not cooperating. I kind of was going crazy trying to figure it out. The counts again for 78 to 85, that's obviously not going to be 1, that's going to be 8. The 1K SIP resistors that are kind of down here, so on the factory board, there's one here, there's one next to that, PIA. Those are 10 pins, but then they are bus. So they're bus, they're not a network or an array, they're bus. And then count on the 2.2 kilo ohms again was off, it should be 14. The count on the 27Ks, that's going to be a total of 4 there. R90 all by itself shouldn't be 4 resistors, it should be 1. I also don't know why there's two entries for 270K. These can probably just be together and then be that 4, so that's kind of odd. And then 97 to 100 would be a total of 4 resistors there. All the transistors seem to be fine. These are readily available, so no suggestions there. And then I first found the error with R102. So that's over in the sound section. That's this guy. This was the one that was listed as 9.1, but should be 9.1K. And that was causing just no sound, being just a buzz, no audio tunes, I should say. It was making a sound, it was just noise. And then after that, the sound started working during gameplay, but it was kind of buzzy, and during a tracked one, it was very, very buzzy. It was one of those things where if you were in a crowded room, you probably wouldn't hear it buzz, but if it's the only thing on in the room, you would definitely hear that something's not right. And again, I could compare it back to the factory board, and it was buzzing a lot more in a tracked mode, especially, and it was kind of corresponding to the displays. And what I found out was D12 here is listed in here as a blocking diode of 1N914. But on the factory board, it's actually right next to U31. And I have it removed because I had to plug it into this board to see if it would fix my issues. This is actually a Zener diode. D12 on a factory board is actually a 1N964B, which is, I think, a 13 volt Zener diode. And I stole the one off of here to fix this one. And it actually took care of that buzzing sound, and the sound seems normal now. But again, this is an obsolete part. You might pay a couple bucks for that one Zener diodes, but I think I have to look at a list. I think that's a 13 volt Zener diode. So there's going to be a more cheap, or a cheaper, more modern replacement for that. That's probably going to be less than 50 cents. So D12 needs to be changed to that to take care of that buzzing. And again, that buzzing was kind of going right with it was getting worse with the displays, and D12 is in the circuit for the displays. Some of the miscellaneous stuff, 5K pot, this thing is super sensitive. You could probably get away with maybe a 2K and have more reasonable range, because this is probably cracked at 10% and the volume's almost too loud. The ferrite beads, I've never had to purchase ferrite beads before, and I can't remember which ones I did, but they seem to work fine. I don't know if there was a way to purchase the wrong ones there. And then again, with your quantities, kind of order some. There might be some pre-bent ones. I think I bought some kinked ones. They're supposed to be mounted vertically because they were half the price as the axial ones, and then I just bent them all by hand. The switch, you can get a pretty close switch here. This is the reproduction board again. But the difference between this one and the factory one is it's actually the exact same switch on the inside, but there's a metal bracket that mounts to the outside, and then is ground as kind of a support. I couldn't find that bracket, but I found the same switch. So this switch isn't quite as stable as the other one, but I don't plan on having to push it very much. And then again, the TO3 is that huge ass heat sink if you're going with a Spendy 323 regulator. And then the test points, there's test points 1 through 16, so that should be 16, right? Nope. I'm guessing they looked at the very bottom test point, which is test point 16, and thought that was it, but there's actually another test point 17 up here. And this is kind of an important one because I think this is the one that you ground out. You can go from here to here if you're trying to get into test mode. So again, just a bunch of little annoying errors, and it was frustrating to build this board, and now it works. So I'm happy that I got it to work, but a lot of frustrating errors that I'm assuming someone has already gone through, and they should have probably been including that information when they send these out for people to build. Other recommendations, I would say always socket your chips. The only thing on this board that's not socketed, because I was chasing sound issues, is I actually soldered that 339 down, thinking maybe it was making a bad connection, causing no sound. But then once I figured out it was elsewhere, I just left that in, rather than heat cycling the pads again. And then in terms of like build order, I usually do all the axial stuff first. I use Captain, I don't know if it's Captain tape, but heat resistant tape them down. And when you're building these, try to go for the shortest parts first, and then work your way up to the tallest parts. That way when you're flipping things upside down, excuse me, I have a really sore throat today. That way when you're flipping things upside down, you're not excessively wearing down all these tall parts that everything's sitting on. Also, when you're building this, be aware that these two are dip switches, and don't try to install a socket there because it's the same size as the sockets. But I think I'll stitch in that video of the sound issues. For now, we finally have a working Reproduction ice cold beer / Zeke Speak PCB. Hope this helps you out. So the Reproduction PCB's in there now, but I'll describe what it was doing because it had 2-part errors on the bill of material. When you first power up an ice cold beer, you're gonna hear kind of a buzzing for about a second or two as the program loads and the game board controls the sound output. It'll actually go quiet. But with the error that was on D12, it would have a constant buzzing during attract mode, and it got worse when the score display was going. And then the other error with R102 was that it was producing none of the game sounds. It was just constantly buzzing through attract mode and through gameplay mode. So I'll power it up here, and then we can hear that buzzing right away. So powering on. So there was that much buzzing for the entire attract mode, and the lights will start flashing here. So now it's in attract mode. So there was that loud buzzing where you might not have heard it if it was in a crowded arcade, but if it's the only thing on in the room, you definitely would hear it. And then the buzzing seemed to get worse and correspond to every time the display was on in attract mode. So now it would be a little bit better, but then once it started displaying something, it would actually get a little bit worse. And then with the error that was on R102, you'd actually get no gameplay sounds at all. So I'm gonna drop a coin and you hear the beer crack open. And then when you started the game, again, it was just loud and buzzing noise. Now, none of the game sounds actually worked. It was just electrical noise. So you got no tunes. You obviously didn't have any up or down sounds or any of the heartbeat sounds to hurry up and finish the mode.